Well, hello again, class. This is Math Minutes video number 28. We're going to learn the difference between perpendicular and parallel slopes. So turn in your notebooks to that lesson, and I believe that is page 48. So, page 48, parallel and perpendicular lines. We have a nice little picture right here. Parallel lines. Parallel lines are lines that what? Right here. Never intersect. What are perpendicular lines? Perpendicular lines meet at 90 degrees. They'll always be perfectly square. You can determine if two lines are parallel or perpendicular by comparing the slopes of each linear equation. What that means is I don't even have to look at the lines on a graph to be able to determine what they're going to look like. Parallel lines have slopes that are identical. Perpendicular lines have slopes that are opposite and inverted. And we're going to look at a few examples and then practice graphing them, and it'll make more sense to you. Example A. These two linear equations are parallel lines. How do I know that? Parallel lines have slopes that are identical. What are the slopes in these two lines? Well, we know that the m, whatever value is in the m, is our slope. So here we have 2 and we have 2. So without even drawing these lines, I know they're going to be parallel on a graph. In this example, these two linear equations are perpendicular. Without graphing them, I know that because this first slope is 1/2. This slope is -2. Well, let's look. Perpendicular lines have slopes that are opposite. What that means, the first one is positive. That means the next one has to be negative. If the first one were negative, the perpendicular slope would be positive. So they are opposite and they are inverted. Inverted is the big mathematical term that means you're simply flipping things upside down. So 1/2 becomes 2/1. And we know that any fraction that ends up with a 1 underneath is really just a whole number, which is why we don't even need to write it. So these two are opposite and inverted. So let's take a look at what these lines look like on a graph. So turn to your next page, page 49. Let's look at example A, and here the equations are written again for you, and let's graph them. Our first equation, well, how do we graph lines from y equals mx plus b? We start at the end. Let's start at +1. From there, we plot our next point using our slope. Our slope here is 2. Well, that means 2/1. That means I'm going to go up 2/1, up 2/1, and that is what my first line looks like. Well, let's look at our second one. Start at the end, -3. 1, 2, -3. Slope, 2/1. Up 2/1, up 2/1, up 2/1. And if I draw this, I know it's without a ruler, fat little marker, you can see that these lines are parallel. Again, I didn't have to draw that. I know that by looking at the slope. So let's take a look at example B. Let's graph our line. Let's start at the end, +3. Our slope is 1/2. So 1/2, rise over run. I'm going to go up 1 and to the right 2. Up 1 to the right 2. And there is our first line. Well, let's look at our second line here. Start at the end, +5. So there we are. That's where it intercepts. And our slope this time is -2, and we can put a 1 under it because remember we have to have both parts, a rise and a run. So from this point we're going to go down 2 and to the right 1, down to the right one, down to the right one, and let's draw that line. And you can see they are perpendicular. If we know a little bit about geometry, we know that that little square means it's a 90-degree angle. It's meeting perpendicular. So there are examples of those two equations. So let's turn to the next page, page 50, and let's just do a little practicing on determining some slopes and identifying whether they are perpendicular or parallel. I've been given a slope of 2. What would the perpendicular slope be? Perpendicular has to be opposite, so this is positive, so I'm going to make it opposite. And invert, I'm gonna flip them. So this is really kind of 2 over 1, so it's going to be negative 1 over 2. That's my perpendicular slope. Here I've been given a slope of negative 3/4. Perpendicular, well, opposite is positive, and then I got to flip them over. Instead of 3/4, it's going to be a positive 4/3. Here's a slope, 1/2. What would the parallel slope be? Parallel is the same. We don't have to do anything to it. How about this one? We have a slope of negative 8. What would the perpendicular slope be? Negative, opposite is positive, and this is really 8. If you have to do this to help you, think of it as 8 over 1. It's going to end up a positive 1 over 8. Here we have a slope of 2/3. What would the parallel slope be? It doesn't change. It is 2/3. So something that we have to pay attention to when you're doing your math problems to really read your directions. Are they asking for perpendicular or are they asking for parallel? So just be aware of that when you're going through your assignment. Now let's just identify, are the following pairs of lines parallel, perpendicular, or neither? What happens when two lines are crossing like at an angle? They're neither parallel nor perpendicular. So that's what neither means when they do something like that. So let's look. We don't even have to do any like real math. Let's just look at our slopes, right? What are the slopes of these two lines? 1 and 1. They're the same, so they are parallel. Our second line, let's look at our slopes. We have a positive 1/2 and a negative 2. Positive 1/2 and negative 2. And if we do that, put our 1 underneath it, we can see a little easier that these two lines would be perpendicular. Let's take a look at these. Slope is 3. Slope is negative 3. What are they? Well, they're opposite, but are they inverted? No, they're opposite, but they're not inverted, so they are neither. And how about the next one, number 9? Let's look at our slopes. 14x and 1/4 x. Well, they're just completely different, so they're neither. That does not meet any of our criteria for perpendicular or parallel slopes. Let's look at our last one. Negative 1/4 and 4. Again, if this makes it easier, let's write it this way. Negative 1/4. How is a whole number written? 4 over 1. What's our criteria? They're opposite and they are inverted. So they, in fact, are perpendicular lines. So if we remember just the simple rule about opposite and inverted and read your directions carefully, we shouldn't have too much problem identifying lines by their equations, whether they're parallel or perpendicular. So again, come to class with your completed notebooks and I will see you there.